Hi, class. It's Miss Culver working out the 3.7a problems that you had questions on. Starting with number two, this is where we had been at. We had a material that was 24 by 24 inches, and they asked us to cut out squares and fold up the sides to make an open box with an open top, and they wanted the maximum volume. So what we had figured out was that the height, length times width times height for the volume, that the height was X, right? Because when we cut out the squares and folded it up, they were X tall. And that because the base was still a square, but instead of being 24 by 24, we had cut two X's off the sides, right, to fold up. So the length was 24 minus two X's, and so was the width. So length times width times height. So we were trying to maximize this volume. And by the way, when I take the derivative and find the critical point, that is going to be the maximum because I know what the minimum volume is. The minimum volume is 0, right? I could make the height of that, that box so small that the volume would be nearly 0, right? So logically speaking, we don't really have to do a first derivative chart. Let's go ahead and take the derivative. So the derivative would be, I'm going to use the product rule here. The derivative, I'm going to use the chain rule. So the derivative of the first term would be the derivative of anything squared is 2 times anything to the first power. By the chain rule, I have to take the derivative of the inside function, which is a -2. Right, so there's the derivative of the first term. I keep the second term. Plus, I'm going to keep my first term and take the derivative of the second, which is 1. Okay, so let's clean this up a little bit so it's easier to set equal to 0. Okay, so let's see. There is a base of 24 minus 2x in each of these terms, right, separated by this plus sign. So that's 24 minus 2x. So this one is gone, and this one is to the first power. So let's see, this is 2 times -2. This is a -4x here, minus 2x plus 24. So it looks like what I have, oh, sorry, parenthesis got in the way there. What I have left is 24 minus 6x. Again, 24, and then minus 2x and minus 4x. There we go. So let's take the critical points. Where is this undefined? It's a polynomial, so it's defined everywhere. But that's not really true in the physical world. We'll talk about that in a second. Where is this equal to 0? Well, luckily this is factored, right? So this first term is 0 at x equals 12. And the second term is 0 at x equals 4. Okay. Why is the only critical point 4 though and not 12? Because class, what we had is we had a 24 by 24 right here. And we were wondering what x's can we cut off here to fold up and make a box, right? Fold up here. Well, take a look. If my x is 12, that means I cut 12 off from the right and 12 off from the left. I've cut off 24. I've got no base. So in the real world, logically and physically speaking, we cannot have a 12, right? If we had stated that ahead of time what our logical domain is, it would have been between 0 and 12, right? But we just found that now. So that would be where x equals 4. Again, it is cubic. There has to be like a max and a min. We know what the min is, right? So we know that this has to be the max. I don't even need to do a first derivative chart. You can if you want, right? Going from a side of 0 to 4 and then 4 to 12, and you'll find it's a maximum, but it's got to be because I know the minimum is 0. And so let's see if we actually answer the correct question though. On number 2, what did they want from us? Did they want the volume? On number 2, and verify the maximum volume from the graph. Okay, So we have that happens when we cut out an x equal to 4, and they want the actual volume. So we'll put the 4 in here, and work out that volume. So I'm going to do that. So let's see, that would be, well, actually, that's 24 minus 8 squared, right? So that's 16 squared times 4. So 1024 is the volume. Was that inches? Inches cubed is the actual volume right there. Okay, you had also asked for number 13, right? And that was the distance formula again. So that was like the number 15 that we did. Okay. So I'm going to draw myself a picture on number 13. They are giving us on 13, f of x equals x squared. So we know what that looks like. And they also give us the point 2 and 1/2. Notice this point obviously is not on this graph, right? When I put in a 2, I get a 4, right? This is 2 comma 1/2. And what the picture would look like, I know what my x squared looks like, right? And then 1, 2 1/2 is like right here. And what they want to know is at what point would you draw a line to hit that parabola so that so that this distance is at a minimum. Distance is a minimum. Okay. Again, a couple things I want to point out to you here. I'll draw this a little bit bigger. This point on the parabola, I can do better than saying that it's an XY point, right? This point on the parabola right here, whatever x I put in, my y is actually an x squared, right? It says it right here. That's a y equals x squared. So I have the point x comma x squared, and I have this point, I'll write it bigger, 2 and 1/2. And I want the distance between them to be at a minimum, okay? So we've done the distance formula a few times, so I'm just going to go ahead and write that. So I'm going to minimize the distance formula, right? And that would be x2 minus x1 squared plus y2 minus y1. Oh, yep, I did that right. I'm going to check and make sure I did though. x2 minus x1 squared plus y2 minus y1 squared. Okay. Now, first of all, I'm going to do some math underneath here. Let's see. I'm going to square both. X squared minus 4x, right, plus 4. Plus, this is going to be x to the 4th. And let's see, that would be minus 1/2 x squared minus 1/2 x squared is minus x squared. And then plus 1/4. Okay, clean this up a little bit more. Let's see. This is going to be an x to the 4th, right? Got that. Plus x squared minus x squared is gone, right? Minus 4x. And 4 and a 4th. Wow, they did make this hard, right? I'm going to call that 4 16 fourths plus 1/4 plus 17 fourths. Okay. Oh, so I finally wrote, the distance formula here with these points as best as I could. Okay, now I want to point out to you again that I don't actually have to minimize this entire expression. I just need to minimize what's the radicand, what's under the square root. If I minimize that, the square root will be minimized, okay? So I'm going to take the derivative of this, right? Because I want to know where the minimum is. Again, when I get a critical point, I know it's not the max. I know what the max is, right? The max would be infinity. From this point, if I made the parabola keep going up, I could make an infinite distance from this point to a point on the graph. So I do know, logically speaking, if I get a critical point here, that it is a minimum. Okay, so I'm going to take the derivative here, 4x cubed minus 4. Critical points. This is a parabola. Oh, sorry. 4x cubed minus 4. Yep, now better. Undefined, this is defined everywhere. It's cubic. Where is this equal to 0? That would appear to be at 1, right? At x equals 1. There we go. So what does that mean when I get an x equals 1, right? You can see when I put a 1 in there, I get a 0 out. That means at this point on the graph, my x is 1 and my y is 1. So apparently that is the shortest distance on the parabola, y equals x squared to this point 2 1/2. Just to be safe, because I was just doing silly things over there, I am gonna check, and it is good. All right, number 9 and 11. Yeah, I could see where you would ask 9 and 11. It does involve perimeter and area, and then they flip the idea. Okay, so this is very much like on the AP exam because it's a little smaller, it's a little easier to understand, and we don't want to spend tons of time on any one problem. Okay, so on number 9, you have to read the bold first. Find the length and width of a rectangle. I'll just call this, that was not a good rectangle. Length and width of a rectangle that has the given perimeter. The perimeter equals 80 and a maximum area. So they want us to maximize the area. All right, well, my area is length times width, right? That's what I'm going to take the derivative of, right? I can't find the max or min of the perimeter. They gave it to me, it's 80. Now, what is the perimeter equal to? 2 W's plus 2 L's. Okay, so before I write the derivative for this area, I do believe that I want one variable. So I'm going to work to get a variable alone here. Let's see, from here, how about I'll get the L alone? So that would be 80. I'm going to subtract the 2 W's and divide by 2, and that's going to equal my L. So 80 minus 2W divided by 2 would get the L alone. Notice I can do a little bit better. I can divide everything by 2. 40 minus W equals the length, 40 minus W. Notice that that actually makes sense. People, 40 minus W equals L. Take a look here. If all 4 sides add up to 80, that means just one length and one width adds up to 40, right? And that means then whatever the width is, right, whatever the length is, that the width is 40 minus that, right? So this actually makes sense. So right here for L, I'm going to put in 40 minus W. So I'm trying to maximize the area. It is now, my length is 40 minus W times W. And you're welcome to take the derivative now, or we could first just multiply out 40W minus W squared, right? Just so we have our nice little power rules. So let's take the derivative, and that would be 40 minus 2W, right? So critical points, undefined, it's defined everywhere. Notice though, we could have said something about this domain, right? What are we shooting for? The length and the width. Obviously, like one of the sides can't be more than 40, right? We wouldn't be able to, we wouldn't have enough left for the rest of the perimeter. Where is this equal to 0? That happens at W equals 20. Okay, again, they were asking us to maximize it. Could I make a first derivative chart going from a side of 0 to 20 and then 20 to what's the most we said we can have 40? Yeah, but I know this is the maximum. I know what the minimum area is. It's 0 if I make it really long and really thin, right? So my W equals 20, and then that would make my length equals 20 also. When you know, right here, I made a little, when I put a W in, 20, 40 minus 20, I get my 20. Again, not a surprise that it comes out to be a square whenever you are trying to maximize, making a regular figure where all sides and angles are equal is what will maximize area and minimize perimeter. Okay, so that was number 9. Number 11 then was just kind of the other way around. Number 11, find the length and the width of a rectangle that has the given area in a minimum perimeter. Okay, so let's just call this length and width. Right, and they, let's see, they want that they're telling you that the area, which is length times width, equals 32 square feet. Right, that's the area. So we're not maximizing or minimizing that. They gave it to us, and they're trying to get us to minimize the perimeter. Right, again, if this was a pen that you were making and you wanted it 32 feet squared in area, you might want the minimum perimeter, right? Because that would be fencing that you would have to pay for. So this kind of makes sense. So notice again, I'm trying to minimize the perimeter. And when I put in, I have 2 different variables here. So I'm just going to get the W alone, right? So I will divide both sides by L. So that way I can make this substitution that W equals 32 over L. So let's go ahead. So I only have one variable, 2L plus 2, and my W is 32 over L. One more fix up before we take the derivative. Oh, that's an L. I'm writing random numbers. Why not? There we go. 2L plus 64. And I'm going to put that as L to the -1 because I'm about to take the derivative. Okay, so let's go ahead and take the derivative. That would be 2 minus 64 L squared. Okay, I can already tell, let's see, critical point, undefined. That's where L can't be 0, but we knew that. We wouldn't have a rectangle if the length was 0. Where is this equal to 0? I can almost tell, right? This would be, I think it's the square root of 32, right? Because when you look here, the square root of 32 squared is 32, 64 divided by 32 is 2, right? Can't we? Certainly I can subtract a 2, do all kinds of things. But aren't I right? Let's check it out. The square root of 32 for the length. Again, the square root of 32 squared is 32. 64 divided by 32 is 2. Yep, we got it. They would probably most write that as 4 square roots of 2, though, would be the length, right? And to minimize the perimeter. Okay. Let's see. Do we need to work on to see if it's actually a maximum that we were given? Let's take a look. We haven't done that in a little bit. Let's do that. So that was our L, right? So our interval for L, make sure you can still see this, goes from 0 to 4 square roots of 2. And then from 4 square roots of 2, let's see, what's the most that L could be? It had 32 square feet. So the most it could be is 32, right? Let's do a test value. Let's call this 1 and let's call this, say, 30. Why not? Right? Let's check the derivative. Right? Where's the derivative? Where was it? Right here. Right here. All right. When I put in a 1, I get a positive out. Oh, negative. Right? 64 divided by 1, 2 minus 64 negative. When I put in a 30, okay, that makes that I get a positive. Right? And that is in fact a minimum. Right? Decrease and increase. And that is in fact a minimum. Okay. Did they, what else did they want from us? They also wanted the width, right? I'm pretty sure this probably came out to be a square. Well, I made a little formula here to get me the width when I have the length, right? So I will put in the width is equal to 32 divided by 4 square roots of 2. Let's see. This is for 8. And 8 over the square root of 2 is probably correct. They probably didn't make it look that way. They probably multiplied the top and the bottom by the square root of 2. Notice that the square root of 2 times the square root of 2 is 2 in the denominator. That cancels out and leaves a 4 here. 4 square roots of 2 for the width also. And the length was 4 square roots of 2. Notice that makes sense. It's a square, right? That always seems to get maximum resources out of maximum use out of minimum resources. Let's take a look at number 22. Just notice, to help myself not get confused, notice how I mark what I'm trying to maximize and minimize when I have other information, because otherwise it gets confusing as to what I'm actually using. So I always keep that marked to remind myself what I'm going to be taking the derivative of. Okay, on number 22, let's take a look at what that is. A maximum area, a rancher has 400 feet of fencing with which to enclose 2 adjacent rectangular corrals. What dimension should be used? So that would be the X and Y. So the enclosed area will be a maximum. So here's the picture that they're showing. Notice what the farmer has done was divided. This is one large rectangular area, but divided it into 2 pens, right? So that might have been for larger animals and smaller so that they're all safe, or 2 different kinds of animals. And they say that this is 400 feet of fencing. Now, note, and they want the maximum area because obviously the fencing costs him money. Okay, he or she, I can't remember whether it says. Notice that this is the fencing, right? If I marked it all, that's my total fencing. So my total fencing is 400 and it equals 4 X's plus 3 Y's. Okay, that's my fencing. Obviously, I'm not trying to maximize or minimize the fencing. They gave me how much they have. I can't maximize it or minimize it. They gave it to me. They are trying to maximize the area. So I'm going to write that. Now, the idea here is that this piece of fence right here does not take away from the area. So the actual area is, this side is 2X's times Y. Or if you looked at it different, the total area would be X times Y plus X times Y, which would be, right, 2XYs. Right? So we want to maximize this area. Again, our main problem before we take the derivative is we have 2 variables. Let's get the Y alone here, right, above in the secondary information, and then we'll put it here. So let's see, I'll take 400, I'll subtract the 4X and divide by 3, and that will get the Y alone. It's minus 4X divided by 3. And I'm going to put that right here. So to maximize that area, that's 2 X's times 400 minus 4X. Now, if you don't mind, this common denominator is 3. I'm just going to write separately because could I go ahead right now and take the derivative? I could, but I think I got a product rule, all kinds of stuff. Why don't I just distribute the 2X right here and here? And maybe what I have will be simpler to work with, right? So let's take a look. I always base the camp like really quick because I all of a sudden have a scared feeling that I'm not recording all this and that I have to do it over. I'm too old to do this again, right? So anyway, I'm not taking the derivative yet. I'm just simplifying this so it's easier. So when I multiply here, that would be 2 times 400, that's 800 over the 3, and I have this X minus, here I'm going to have 8X squared over 3, 8X squared over 3. Okay, let's come on up and take the derivative. Again, when I get the critical point, I'll know in this case that it is a maximum. I know the minimum area is 0, but then we want to be able to fit any little animals in, right? Okay, let's take the derivative. This would be an 800 thirds minus when I'm going to bring the 16 out front and multiply it, that would be 16 thirds x. I'm just checking to make sure I did okay. All right, so critical points, undefined. This is defined everywhere. Again, though, let's please remember that this fencing, the domain of x is actually restricted. Like the most it could be is 50 or 100. The most it could be is like 100, 100, 100, 100. You just used all your fencing, right? So there really is a logical domain here. Where is this equal to 0? Let's see, I'm going to subtract. So I'm setting this equal to 0. Gosh, I can kind of tell again, can I? You know, you're probably like, why is she short? I could subtract an 800 thirds. Now I have a negative on both sides, multiply it by, make it positive, divide by 16 thirds. But really, 800 thirds minus 800 thirds, right? So really what's going on is right here, is if this was a 50. See, what I was looking at is the denominators are the same. For this to be 0, it would have to be 800 minus 800. And 16 times what is 800? So that must be a 50. X equals 50. Okay, again, I could do a first derivative chart. It would come out to be a maximum. I would go from 0 to 50 and 50 to 100. Right, and you would see that's a maximum, but logically speaking, it has to be. They asked us for the dimensions. So my x is 50. Let's get the y. Notice every single time you made yourself a little formula that does that. When I put in a 50 here, that's 400 minus 200 is 200 thirds. So x equals 50 and y equals 200 thirds. These were in feet, I believe. Will maximize that area for the amount of fencing that you have. So fun stuff, isn't it? I love that you can really apply it though. You really can apply it. So I hope you have a great day and you are one day closer to your winter break.